So, up to now, we have been looking at this idea of a complex number. And I really wanted to kind of understand the geometry of the complex numbers. So, for example, if I take some complex number, let's say 1 plus I, okay, and if I multiply it by another complex number, so I'm just going to say multiply it by just some random complex number. Now, geometrically, what is going on here? So if I take a complex number, any complex number I like, and I multiply it by 1 plus I, what is the action of multiplying by 1 plus I on the complex plane? Good. Good. Now my question is, how much is the stretch by and how much is the rotation by? So you're stretching it by how much? So have a look. Okay, I've taken 1 plus I there. We can take any random number on the complex plane, and when we multiply by 1 plus I, we do this stretch, we do this rotation, and we see where that new number ends up at. So, yeah, it's root 2, isn't it? Yeah? So it's a stretch by r, right? It's the stretch of the modulus of that thing. How much is the rotation of the complex plane by? Yeah, good. So it's by the angle, the argument. Yeah? So that's basically what's happening when we're multiplying by 1 plus I. We're getting that stretch by a factor of whatever the modulus is, and we're also getting a rotation by a factor of whatever the argument is. And we said, I wonder what happens then if we keep multiplying by 1 plus I. So we take 1 plus I and we keep raising it to higher and higher powers. Okay? So if we do this, yeah, generally, what is 1 plus I in polar form? So let's work it out, okay? What do we need in order to work with it in polar form? We need r and we need theta. So what's r with 1 plus I? Yeah, it's root 2. It's 1 squared plus 1 squared, right? Equals theta. And, equals, what am I doing? Root 2. And theta, how do we work that one out? I mean, it's not that difficult, right? So tan inverse of y divided by x, effectively, the imaginary divided by the real. So 1 divided by 1. So what's the tan inverse of 1? So think about it on the complex plane. I mean, we've got it here, right? 1 plus I. The length of that line is root 2. The argument is equal to... Excellent. It's 45 degrees, right? So it's pi divided by 4, which means that if we take 1 plus I and we put it into polar form, we get what? Yes. Good. Yes? I sine pi over 4, yeah. Okay, now that is in polar form, right? You've got your r and you've got your theta. And what my question is what happens if we raise this to higher and higher powers of n? This is what we finished off on Friday, okay? So what happens if we raise this to higher and higher powers of n? So you remember, think about this idea. When we multiply by complex numbers, in fact, I've got it here. When we multiply by complex numbers, we get this stretch which happens. Okay, so we're stretching the entire complex plane. And we're also getting this rotation which happens as well. So if we keep multiplying by 1 plus I, we keep stretching by a factor of root 2, which means that the new argument will just be root 2 times by itself that many times. So it would just be root 2 to the power of n. You're happy because you keep stretching the plane by a factor of root 2. But what also happens, you get that rotation like n times, yeah, however many times you've rotated it by. So you're going to get cos of n pi by 4 plus I sine of n pi by 4. Is that okay? Do you remember that? Okay. Do you remember the name of this? Like if you take a complex number and you keep raising it to higher and higher powers of n, do you remember the name of this formula? Who came up with it? He was a French guy. De Moivre? Yeah, good. So this is de Moivre's theorem, right? It's basically the idea that if you take a complex number and you keep raising it to higher and higher powers of n, this is how you work with it. It's basically root 2 means you're stretching the plane by that many times, and you're also rotating the plane by that many times as well. Okay, so you raise r to the power of n, and you times theta n times. Okay, so generally you can write z to the power of n will be r to the power of n cos of n theta plus I sine of n theta. Is that okay?